morning. In this presentation, I'm going to talk about a recommender system of learning resource based on cognitive map. In this presentation is represent the world around a smart classroom. This is one of the components of the smart classroom. In this presentation, I'm going to present the main aspect of this recommender system. And for that, we are going to give some idea of the cognitive map of the element. I'm going to explain the one type of recommender system, the intelligent recommender system, where this cognitive map is part, because there are a lot of recommender systems, but this is one type of recommender system that can be implemented very easy with a cognitive map. I'm going to explain that in this presentation. I'm going to give some idea about that. The main motivation here is that in one smart classroom, we need to have different components. One of the main components in one smart classroom is the one recommender system of learning resource. But this recommender system can be autonomous. That means they need to be, they need to have one behavior, one autonomic behavior. And that defines a new type of recommender system that we call intelligent recommender system, because this type of recommender system need to have three elements. Need to represent the knowledge about the environment, the learning environment, need to have the capability of learning, and need to have the capability of reasoning. That means it's a new type of recommender system with this set of behavior, of this set of components that is different that the classic, the knowledge-based recommender system that use only the capability of inference from a given knowledge representation. Here we introduce the idea that we need these three capabilities together. Normally, we can find in the literature a cognitive map, like resource, like recommender system, but they don't have these three capabilities together. That is the first paper that have this, that consider this aspect together. One smart classroom is something like that, where we have different intelligent objects, or maybe another type of object, and where we see the different application, the different software, like objects, that are intelligent object. One of these is a recommender system. And this recommender system, remember that I have told you that they need to be autonomous. That means they need to act according to the information that it can catch. They need to act in autonomous way. This is the classical, this is a type of middleware for one smart classroom, and normally one recommender system belongs to the first level where we define the different device. That means the intelligent object, but where we define the different application that compose the different software that compose the smart classroom. And one of them is the recommender system. in this case, or for this context, is that we have developed how a recommender system, where the recommender system is one of the software that compose the smart classroom. This is the one list of the different components. Okay, the main point here is that one intelligent recommender system needs to have three capabilities. The reasoning capability, the capability to represent the different knowledge about the user, in this case about the learning resource, about the domain of the course, etc. And they need to have the capability to learn the new information, the new aspect that in one dynamic smart classroom can have. For that, we propose different components. One intelligent recommender system needs one description, very good, about the user. We define different concepts, different attributes to describe the user. Remember that one recommender system needs to define the relationship between the user and the product, in our case, with the learning resource. And for that, we need to describe very well the user profile. We describe very well the item profile. Here we have the different attributes about the user profile. For example, the language, the education, the occupation are some of the concepts or some of the attributes that we need to define. At the level of the item, we need to define the name, the description, the version, that means different concepts to describe one item, one product. And we need to define some concept specific to the domain. For example, if we are in the learning environment, we have a specific concept to describe, for example, one smart classroom, the components of one smart classroom. And the other concept that we include are concepts about information that can allow describe can describe very good one specific information to infer, for example, some aspect that can be interesting for a given user. That means here we include information that describe a specific aspect about the user that we can infer according to the behavior that the user can be, the relationship that the user can have with other people. That means here we can define the influence that in a given social context a user can have. Opinion, preference, trends. That is the type of information. And normally, this type of information is very important because it's a way to infer information from your other user that can be used for this specific user that we can recommend something. Now I'm going to explain one application of the intelligent recommender system based on cognitive map, in our case, in the context of smart classroom. In our case, we have described the profile of the user using one standard. In this case, we have used the IMS standard that describes very good one student and professor. And to describe the learning resource, we have used other standard, the long standard in this case. We propose, again, a multi-level cognitive map, where in the first level we describe the different concepts that we have, we are going to infer. That means here we have the concept that describe the recommendation, or the concept that describes the critics about one product, the opinion about one product. And the second level, we have the different profile, the profile to describe the item, in this case the student, and the profile to describe the learning results. In our case, we have tests that is description, the profile that we have defined in the previous slide, can describe or can follow very well this standard, the LON standard and the AMS standard. That is a very good, very important point, because that is a good way to understand that we can use our general description of the use of an item in different contexts. Here we have the different concept. The grade concept describes the first level, and the weight concept around the grade concept describes the second level. And we're going to infer the concept in the grade concept in the first level. Here we have some meaning about this concept. For example, preference is a concept that describes if maybe one learning resource can be interest for a given user. But we have other types of concepts different to the recommendation, and our concept about property of the learning resource. For example, usability or the interpretability of a given learning resource. That means we have different types of concepts to be fair. One aspect about the learning consideration, one consideration about the learning aspect of how cognitive math is that we have the definition of the cognitive map has been carried out with experts, and we have used some procedure, the typical procedure when we use different experts to define the cognitive map. In the literature, you have different approach to do that. And then we have implement one adjustment of the weight with one initial experiment where we know the recommendation. In this way, we have test if the initial cognitive map follow this recommendation that we know. And we have adjust, we have date the way to follow this correct behavior. Then we have developed two tests. One first test to recommend, to know if a given concept can be, if the given learning resource can be recommended to a given student. In this case, we have used only the concept linked to preference to know if this relationship can be determined. And in a second type of experiment, we have studied the characteristic in the second experiment, the characteristics of the learning resource. That means we're going to infer if these characteristics are present in one specific learning resource. That means here we're going to have two different utilizations of how cognitive map. In the first case, this is the first case. In the first case, we need to specify the student characteristic and the learning resource that we like to recommend. And in this case, we're going to try to find the matching between the student characteristics and the educational results. And according to that, if we modify the student of the learning resource, we can obtain different type of information. We can infer different type of information. For example, this case, for this student concept and this specific learning resource, the first column represents the recommendation. For example, this item is not interesting for this student, The user, the other user similar to this student has no use a lot of time this learning resource. This is the type of information that we can infer. But for example, for another student and the same learning resource, we have to find that that is the first recommendation, that means the second column. We for this type of student that here we don't have the information of this student, maybe that this learning resource is interesting. The punctuation is very good, the preference is very good, but for this student, there are no similar students that have used this learning resource. This is the type of information that we can infer from our cognitive map. In the other case, that means when we like to study the characteristics of the learning resource, here we have information of the learning resource, that is the first table. About the student, we don't need a lot of concepts. Right? Look at here, the different here, where we have a lot of information about the learning, about the student, and we have some information about the learning resource, and here we have all information of the learning resource, and we have some information about the student concept, because here we like to study the learning resource. And here we can infer two properties of the learning resource, its usability and its interoperability. We can infer, for example, for three hypothetical learning resource, this information. In our case, for this specific case, the first column represents the information of this specific learning resource. That means each learning resource has a high usability and high interoperability. In this way, we have developed a recommender system based in the intelligent recommender system concept that we have proposed at the beginning. We have used the neologism that we represent in how to study different aspects. That means we can navigate in this neologism not only to recommend a learning resource, we can use for different aspects. And that is the main point, that we have a lot of knowledge that we can explore in different ways. And the fuzzy cognitive map can have, during the implementation of recommender system, the three main capability of one intelligent recommender system. That when we can include the reasoning mechanism, the learning algorithm, and a very good and detailed representation of the knowledge of the specific domain. We need to continue to work in this domain because we need to include new learning algorithms in the cognitive map. There are a lot of learning algorithms that we need to study the way to include this one in our approach. But the main concept, this first work, the main concept has been included with your problem. If you have any question, you can send me one email where this were your question or comment. Thank you.